Now that technology, in some respects, has caught up to human curiosity, we are in a position to gather facts and start trying to answer some of these questions. As residents of the third planet from the Sun, it makes sense to start looking for answers on the fourth. Mars, the red planet. Exploration of Mars began in earnest in 1965, with the first successful flyby by the Mariner 4, and at present there are 3 orbiters surveying the planet and 2 rovers on the surface. Bouncing from one planet to another, however, is not easy, which makes the failure rate of such missions rather high. About half of all spacecraft destined for Mars failed before completing their missions. The Mars Climate Orbiter was a space probe designed to be a smaller, less expensive way to explore Mars in the wake of the 1993 loss of the Mars Observer, and was launched atop a Delta II launch vehicle on December 11, 1998. Its mission: to function as an interplay satellite and communication relay for the Mars Planetary Lander. Together, the Mars Orbiter and Mars Planetary Lander were to map Mars' surface, profile the structure of the atmosphere, try to detect surface ice reservoirs, and dig for traces of water beneath the surface to understand its history and its potential to sustain, or to have sustained, life. In this example, the date is September 23, 1999, and the time is 9:04 a.m. The orbiter's accident took place in Mars' upper atmosphere, physical geographic location, during orbital insertion, the process. In some cases, there may also be a business location, where the name of the company and the business is listed. The outline can be modified as needed to document any relevant location information. The most significant difference was that this was a new design. Finally, we detail each individual organization goal that was adversely affected by the incident in question. The goals reflect the ideal state of an organization here. If NASA was operating at an ideal state, the mission would have gone swimmingly. In this section we record both potential and actual impacts on the goals. NASA launched the Mars Climate Orbiter in order to accomplish specific mission goals like recording changes on the Martian surface and looking for evidence of past climate change. All goals that required the Mars Orbiter remaining intact. The equipment failed before accomplishing any of these goals. NASA lost a lot of money along with the orbiter too. The cost of the mission was $327.6 million total for the orbiter, $193.1 million for spacecraft development, $91.7 million for launching it, and $42.8 million for mission operations. These expenses would thus be listed as a negative impact on the material and labor goal. Finally, as we mentioned before, NASA's failed missions, by their very nature, tend to fail very publicly and in ways that people are able to grasp much more easily than what NASA had been attempting to do. The complete failure of the Mars Climate Orbiter project negatively affected public support for NASA, thus adversely affecting the customer service goal. Now that we've built up all of the relevant goals, a few more causes need to be added to the right to understand why the trajectory was lower than expected. This is where the middle school math teacher would come in to remind us to work in the same units when performing calculations. On September 15, a trajectory correction maneuver had been executed that was supposed to place the orbiter in a prime position for orbital insertion at an altitude of 226 kilometers. In the time between this correction maneuver and the actual insertion, though, the navigation team noted that the orbiter's altitude may in fact have been much lower. 80 kilometers is the lowest altitude that the orbiter could survive in this maneuver. A day before insertion was to take place, calculations had it at 110 kilometers, which should have been fine. Final calculations had the spacecraft at within 57 kilometers of the surface, however, at which point the orbiter disintegrated. What went wrong? The orbiter's flight system software was designed to take thrust instructions in newtons, N, a metric unit. The software on the ground, however, generated instructions in pound force, lbf, an imperial unit. 1 pound force equals 4.44822162 newtons. This, in turn, goes back to what we were saying about NASA's projects involving many collaborators from all over the country. Engineers from Lockheed Martin in Colorado provided the navigation commands for the orbiter's thrusters, while scientists at NASA's Jet Propulsion Laboratory in California operated in metric units, as has long been the standard at NASA.